The outlined techniques are known as blind SQL injection. The methodology of this attack type relies not only on embedding single expressions like OR1 equals 1 into SQL commands. Entire statements or complicated expressions, logical conditions, tests, can be injected as well. You can communicate with server without having access to a server interface by using only information returned or not returned in error messages. This is one of the most popular techniques for blind SQL injection. Another method is a technique that relies on measuring the times needed to execute a query. It's worth noting that this is not the sole alternative. An attacker can try to embed some commands and attempt to delay an execution of a query. If an application responds immediately, the attacker will know that the inserted command has not been executed. If the answer is delayed by, for example, 2 seconds, this is proof that the command has been executed despite no credentials having been directly obtained. Remember that results are visible for us in an SQL editor window. An attacker would not be able to see the results. A database server, as you can now see, will execute any well-formed command. To execute it, however, the instruction must refer to another command that is contained in an object database. The command has to be both syntactically and semantically well-formed. You should not expect an application like Hack Me Travel, to which we're quickly logged in, see the taskbar where we're logged as user, to display entire tables with data when you type select 'from table. This isn't likely. Apart from that, error messages might be filtered and replaced with messages that are more general. This is a good practice as far as application security is concerned, and end users should not be able to see any detailed error messages. Despite this, blind SQL injection is still possible. Why is that? It's because we're able to execute commands that are sure to always be executed. This is the basic idea behind blind SQL injection. If you know such commands, this requires the knowledge of a specific dialect of a given language or the knowledge of the database server. You can ask server questions that will always be answered with true or false. Something is or is not executable. This is obviously a time-consuming solution, but it can be used to obtain all needed or relevant information. Let's use a particular blind SQL injection attack that targeted a really large web application several years ago as a case study. The fact that the attacked application was ASP.NET based is largely irrelevant. All this means is that a given application certainly uses a Microsoft database server. It's difficult to imagine otherwise. The reverse configuration is possible, but if an application is based on ASP.NET, it almost certainly uses some version of an SQL server. A common feature of web applications is that they are publicly available. This is one of their strengths. The attacked application was also public. A logging form in the application required the submission of a login and password. What's more, the form enabled users to reset their password. If a user forgot their password, they did not have to contact an administrator. The process could have been done automatically. This was possible because clicking on the Remind Password button sent a user's password to the email address submitted during registration. It would be absurd to send a forgotten password to an address submitted only a while ago by a user. Attackers checked that after entering a single quote into a user field and clicking on the Send Password button, the application reported a specific error. The query executed at this point by the application might have looked like this. Note that we mentioned a single quote. The above listing has 3 apostrophes. The same was the case with the examples we showed before. We'll come back to this later in our presentations. It's worth noting, however, that the key here is the correct ending of a line. Why are there 3 or just 1 apostrophe alternately? If a command itself used a single quote, to make a quote a quote, it has to be preceded with another quote. This is how SQL is written. And unfortunately, it's not the only language that is constructed in this way. Many languages need to double a control character to make it retain its meaning. We would like to end a string. This means we need another apostrophe. We'll come back to this subject later. When trying to submit a different username, the attackers clicked Send. This prompted a different error message. This was no longer error 500. Instead, the unknown user error message would be displayed. If a true expression was entered into a user field, like OR1 = 1, an interesting message would be prompted. A new password has been sent. We might assume that the server executed the following query. As we saw before, this is more or less the used line of reasoning. At this point, the first user in a table row received an email that contained a new password, regrettably. But let's not cry over spilled milk. This means that we have 3 system reactions. We sent a new password to a user, we got an error 500 message, or a user unknown error message. 3 system reactions have been discovered. Let's try now to find the names of the table columns. We had a chance to see one of the methods used for extracting this data live, using executable instructions. This information can be checked also in a different manner. Take a guess at the column's name and check system reaction. See if this brings an error or not, and if the column is contained in the table at all. As you already know, we can communicate with the application by interpreting messages like user unknown or internal server error. When the column names are obtained, it's time to extract the table name. In order to do this, you can use a subquery that again takes a guess at the table name. The method we saw before was more universal. The table name would be returned in an error message at once. Having acquired the names of the columns and the name of the table, you need to verify if the table name is really correct. This is essential since most database servers' object names are made up from 2 parts. A table name is preceded by a name that is known as a schema. This means that the same table name might be reused multiple times inside a database. You need to be sure that you have both the name of the schema and the table name. You can put a schema ahead of the table name in a query and see the results. Having obtained this information, you can try to read user data. In this case, however, the attackers opted for another solution. They decided to change an email address of one of the users. Why would they do that? Remember that the application sends a new password to an email address supplied at registration. Knowing this, we chose a user who we suspect to be an administrator and update the email address column of this user by entering an arbitrary email to which we'd like a new password to be sent. It turns out that this approach is adequate. The system forwards a password with administrative permissions to the attacker on its own.